Meltzone Podcast from January 23rd, 2019. I'm Tom.
And I'm Stefan. And on today's episode, we are going to talk about our CNC.
Yeah, okay, whatever. Don't care. You're going to MRRF. That is fantastic. Awesome to have you with me.
Yeah, I finally decided to go to MRRF. It has been taking me a while. You have been like kicking me for weeks and weeks. Others have been asking me, will you go to MRRF? And I finally made up my head and I thought, yeah, don't be that shy and just go there. You'll regret it after otherwise.
Yeah, and I've regretted it the years before where I didn't go, and yeah, it's just such a good event. I'm really hoping I'm going to see some of you guys listening right now on the event. I think that's one of the best things about it. It's just such a nice casual hangout, right?
Yeah. Lots of nerds, hopefully.
Oh, yeah. We got plenty of those.
Yeah, and we'll actually... So I booked the same flight as you did. I booked the same hotel in which you're also staying. I hope I can join you in the car from Chicago to Goshen.
Yeah.
Otherwise, I kind of have to walk.
Supposedly last year there was some sort of shuttle service where someone had a 7-seater and driving people back and forth. Maybe I'll post the dates and times when we're coming in and flying back just in the notes below. And if someone needs a ride from the airport, I guess we've got 5 seats usually, so we still have 3. Yep. If 3 people want to cram in the back of the car, but yeah. Yeah, so we're going to be there Friday night, Saturday, and Sunday. So we're going to do the full event. Last year, I kind of messed up my booking. I didn't realize there was something happening on Friday night, but apparently that's like the pre-show where everyone gets to know each other. And that's, I missed out on that. Not this year. Yeah, and Stephanie, you were also kind of mentioning you would like to go to Bay Area Maker Faire?
Yes, I was really thinking about going to Bay Area Maker Faire because I just love being in California. I love the countryside. I love the people there. But yeah, it's already in May, so I don't know if I can make that because just like normal work also requires me to be there from time to time. Well, we'll see. New York Maker Faire would also be another event, which is I think later that year. Kind of a bit later that year. So yeah, maybe this year I'll actually go to more than just like I haven't been on a Maker Faire before, actually. Not even in Friedrichshafen or Munich.
Especially the big ones. Yeah, the Munich Maker Faire. Is it called Maker Faire? Whatever. Make Munich, yes. Munich. Licensing or whatever, I don't know. Because Maker Faire is actually trademarked by the Make magazine.
Yeah.
So yeah, it doesn't compare. I mean, the smaller Maker Faires are nice. The Make Munich, I've been there the last 4 years or so. It's nice. It's nice and compact. But really, if you're just strolling through, you're not going to spend more than half a day there. It's not really something that is, all that massive in scale. But the Bay Area Maker Faire, it's literally, I think it's like 8, 9, or 10 times as big as something like the Make Munich, which is already a rather large fair, I think. Mm-hmm. So yeah, definitely worth it. I would like to check out the New York Maker Faire too. I've heard it has a bit of a different vibe than the Bay Area Maker Faire, which I've been to last year.
Have you already been to the New York Maker Faire?
I have not. I've been to New York before, but not to the Maker Faire.
Well, at least for 3D printing, I guess the New York Maker Faire might be a little bit more interesting because like the Silicon Valley of 3D printing is more on the East Coast.
MakerBot, right? Coast. That's where it started from. Yeah, didn't Prusa announce something last year? Was the SL1 that they announced on the New York Maker Faire?
Ooh.
But yeah, lots of big stuff happening there.
I guess it was at Birmingham, but I'm not sure. Or was it the Prusa?
Was it the multi-material was Birmingham?
I don't know. So many fairs. Yeah.
Yeah, so much stuff happening. Yeah, and there is apparently not during the TCT in Birmingham, there is apparently a smaller meetup. I mean, we know about the 3D meetup Sweden. We know about the East Coast Rap Festival in the US. And apparently last year, either I've missed it or it was just really small. There is now a 3D Meetup.UK on May 18th and 19th in Birmingham. Probably not in the same venue that TCT is going to be in, but nonetheless, Birmingham, UK has an airport. Goshen, Indiana does not have an airport. Just saying.
Yeah, I'll see how much I like it and how many more of these events I can really cram into this year.
Yeah, I mean, they do add up in like the time you invest in them. It's more than just the weekend you're there. It always stretches out to at least 5 days of actual effort. And if you actually want to shoot videos there, it gets even more involved. So yeah, it would be nice if we could go to each and every single one, but it's just not realistic.
Gonna work at some point. That's the thing.
Actual work. Yeah.
Yeah. So I've been seeing that you have been working with Eagle again, doing some PCBs.
Yeah. I mean, I've known Eagle for many years. I've used it just for PCBs and stuff. And just after a while, I picked it up again and I was like, I've got this. It's over there somewhere. This, jumper wired prototype PCB, and it's really ugly and it doesn't actually work. Let me, maybe make a real PCB for this. And yeah, Eagle still works the same way. It looks kind of weird when you open it up the first time because now it has like the Autodesk style to it and different launcher, but it still works the same way. And I mean, PCBs, I enjoy getting nice PCBs made. Like Osh Park PCBs are just fantastic stuff. But also they're expensive if you want larger ones. Then there's dirty cheap PCBs from Shenzhen somewhere. Well, China somewhere. I don't know if it's Shenzhen particularly. And they are, $15 for 10 PCBs of up to 10 by 10 centimeters, 4 by 4 inches. And that is a fantastic deal. And they're okay PCBs, but they just take 1.5 months to get to you. So it's one of those things where you order and it just slows down your project.
Well, on that point, actually, a friend of mine just had been ordering a couple of PCBs from JLC PCB.
Oh, yeah, the guys that want to sponsor everyone, right?
Well, they're at least sponsoring Great Scott quite a bit.
Yeah, I've got like 10 emails from them in my inbox as well.
And well, it didn't really take him that long, like just a couple of days until they arrived. So he had been ordering them, and like a week later, he had the PCBs, great quality, and he didn't spend that much money. It was like just $20 or not even more.
Yeah, I'm going to have to look that up, yeah.
I guess that's still a pretty good option because where else do you get a PCB or 10 PCBs for like under $20?
Yeah, of course we have like the big PCB pool companies in Germany that will make one-off PCBs for you as well, but they're like $70-80 for a single PCB that size for one, not 10. Yeah. So that's, I mean, if you're business, if you're big corporation, I guess business doesn't cut it anymore at that scale. It doesn't matter if that thing is like $5 or $60. It's a prototype, right? It's in the budget. But for us makers, it does make a ding or a dent in the budget if you pay that much for a single PCB that costs more than every other component we use. Yeah, so JIL PCB, right?
JLC PCB?
The J PCB company, yeah.
Yeah. If you don't know who I'm speaking about, just watch Great Scott's video.
Yeah, they're linked there. Yeah, and one of the...
So have you been learning designing PCBs at university, or because this is really something I just don't really know how to do them. I was using Fritzing like 5 or 6 years ago, which is like the easy version of designing crude PCBs, but it's nothing compared to Eagle.
Yeah, so no, actually, designing PCBs is not something, at least in a mechatronics degree, you learn. So as with most other things I know, it's basically self-taught. It's from the internet, tutorials, videos, trying things out, failing at things, and redoing it. Learning the hard way, basically. I did get some like professional input while I was working at Harman. We were just doing schematics, and PCBs would be just one guy that just did PCBs and that really had his stuff down. But it was also like 8-layer PCBs and BGAs and stuff that you don't really want to route as a hobbyist. No. So I learned a bit there, just the basic mindset and basic rule set, but it's not that hard. It's just basically a craft like everything else.
Well, for a mechanical engineer, electronics is already like in Germany, you would say ein Buch mit 7 Siegeln, like something really hard, and I at least understand electronics a bit, but designing PCBs is just another way forward.
Yeah. Well, there's two things to it. There's, first of all, getting the circuit to work, which usually is just, you look at, if you have some sort of IC, you look at the reference circuit in the data sheet and just kind of copy that and change 1 or 2 resistors, and that's it. And then the other one is actually making the PCB. So those are actually pretty separate tasks, but it's not that hard. And I mean, Eagle is free. PCBs, if you want a physical thing, it's not that expensive. Mm-hmm. And start small. Start with something like, I'm gonna show this thing again, and people will be like, please make a video about it. But it's currently, I don't even know where the firmware is. This thing has like 10 components on it. Super simple thing. Auto router. You don't even have to paint or draw the traces yourself. The software does it for you. Super simple.
But you're also working on your mostly printed CNC, so this would also be an option to like make crude PCBs.
Absolutely. Absolutely. So I still have the converted Mendel Max CNC. Yeah. And that's with my Padawan right now. He offered to mill some PCBs for me. And right now I'm just figuring out what the best way is to translate an Eagle schematic or Gerber files into G-code, into a millable G-code that you can use a V-groove router bit with to mill out the traces. And I've not found much yet. So Stefan, I assume you've not done much PCB routing either.
I have done actually PCB routing like 4 or 5 years ago. I designed a control circuit for a barbecue smoker.
Wow, nice. So you do have some PCB experience.
Yeah, I do have some PCB experience, and I routed that myself on my wooden CNC router. But the thing is, with routing CNCs, you don't really have cutting forces, so like every 3D printer will be usable for CNC routing because it's that easy for the bits, and even a 3D printer would actually be more suitable for for PCB routing because it doesn't have any backlash. And you have with these really small, how do you say, pitch distances, or with your traces that are quite thin, you don't really want to have like big backlash because then they might not be there anymore. And not working with trapezoidal
lead screws
with lead screws just removes the backlash problem. So that's quite
absolutely
interesting.
There is, I mean, if you're using the V-groove bits, you're not seeing a ton of cutting forces, you're right. But with a 3D printer, if it's just a standard, if it's a relatively wobbly frame, you would be worried about getting resonances and getting the bit bouncing around. Yeah. And that's not going to make for a clean cut because you do have to push it into your material, into your workpiece a bit to get the bit cutting. So if it bounces around, either you're going to break the bit eventually, or it's not going to last as long, or it's just the routing result's not going to be as good. So you need a bit of rigidity for any sort of engraving or routing.
Yeah, but it's working pretty well. I don't really 100% remember how I did it at that point, but I have just been like exporting the DXF files from Fritzing with the traces, and then used, I think it was Cut2D to like just go around these traces and mill them out. And then I used an additional like 1 millimeter drill bits to drill out the holes, which was pretty handy because then you don't need to do that afterwards on a drill press.
Yeah, you have the CNC already, right? You change your tool, and as long as you don't move an axis, it's perfectly centered.
But this is actually one of the things you really need to think about, because in my old CNC router where I had the lead screws, it is kind of self-locking into position. So changing bits doesn't usually shift your homing position. But if you are using a normal 3D printer, you should actually turn on your stepper motors that
definitely.
the X, Y homing position doesn't change.
Yeah,
but it's doable.
For sure. There's even like the really small spindles. I mean, the sort of 400 watt spindle that I'm going to be using on the MPCNC, I think that is already a bit too large for a 3D printer to be chucked around, because it is rather heavy. It's like a pound or something. So it's, it does add a lot of weights that you don't necessarily need. I think it's heavier than a pound. Well, whatever.
I had been using like a Proxon multi-tool Dremel thing with 80 or 150 watts.
Dremel's a trademark.
For ages, and that was working well for like soft woods and PCB routing and things like these. But yeah, changing my spindle to a more beefier one was the right decision in the end if you want to work with metals.
Yeah, those Proxon tools. I mean, they even make them with the 20 millimeter flange, with like the aluminum flange that you can actually clamp to things. So it's almost like a real router. Yeah. I've gone through 2 of those, and the bearings and the spindle just don't last.
Yep.
I might have been pushing it too much, but well, whatever.
It's a tool.
Yeah, then on the Mendel mix, then I switched it out to one of those 400 watt spindles, DC in that case. And yeah, that worked well after that. And I guess that leads us into the next topic for this one, and that is stepper motors or servos or trinamic in the this or that. Now, the trinamics, why are the trinamics in here? Because they are kind of in between a stepper motor, which has no feedback, so the driver doesn't know what the motor is doing, and the servo, where the driver is knowing everything that is happening on the end and can control the motor in that way. And the interesting thing is the trinamics have a good understanding of what they're actually driving, just like the brushless driver that I have for my MPCNC spindle. I know that's a bit of an arc that I'm trying to span here. But I think I'll link it below. But for the MPCNC, I have a brushless spindle, and it has an RPM display with it. So it has like the driver, and I guess it has a pulse output, and it comes with a little screen. So you can actually regulate the RPM, and it displays it. And I don't think it controls it. It keeps it steady, but at least it has that understanding, which stepper drivers don't necessarily have.
Well, all the stepper motors we use for our 3D printers and, well, my other machines right here, they're just open loop control. They're just dumb motors. You tell them, okay, go a step forward, they go a step forward. If you like hold the axle in your motor, the driver or the motor itself just won't turn and you lose a step. And this is one of the problems. But for 3D printers, it's working quite well. The forces are not that high. You can tune them in a way that your motor is most of the time strong enough to not lose a step. And if you're thinking about if you are doing like a 24, 48 hour print or something like that, these stepper motors are doing like billions of small steps, and then they still know in the end their perfect position by 100th of a millimeter, and that's always freaking me out.
On most prints, I've recently done like a massive. I always make the same face when I bump my mic. I've recently done like a massive print that was almost the entire volume of my CR10, and I think at hour 45 or something, it skipped a step on the x-axis, which is, I mean, it doesn't matter on that print because it's just a big block anyways, but it still happens. Yeah. Right? It's not something that is completely out of the realm of possibilities. The question though is, are we holding ourselves back by using stepper motors and by not switching to something like what are they called? The little boards you put on the back of the stepper motors that we use for the hang printer. People are probably shouting at us right now.
You're gonna tell me. Well, yes and no.
You know which ones I mean, right?
I know which one you know, but I don't know the name at the moment.
It basically, so it's a small PCB. You stick it on the back of your stepper motor, and it turns it into a servo because you also glue a small magnet to your stepper shaft, and that gets read out by a small read Hall sensor. Read? No, it's read is just a switch. The Hall sensor, yes, by a Hall sensor on the PCB, and the driver itself is on that PCB, and it knows where the motor actually is. So. That basically allows you to do so many more things. It allows you to accelerate harder, to not worry about, can I tune my jerk value to that, or do I have to limit my acceleration to something less? You're losing so much of your stepper motor's capability by limiting it to those set accelerations and speeds. Could we be printing way faster and way more aggressively with something that has feedback?
Maybe yes and no. I don't know. I think there is kind of a limit also with the rigidity of the machine. Yes, you can print faster, but then your print quality is degenerating. So at least in hobby machines, I don't really see a big benefit. Especially if you also take a look at the cost of these systems, because they just make stepper motors like almost by order of magnitude more expensive.
Yeah, but I think that's just a scale thing. Because for a stepper motor, you still need drivers. And if you have just your servo that takes step direction and cut out your Lego driver chip entirely and integrate it, I don't think it's going to add that much if you're making millions of those. And the stepper motors were the same way. Stepper motors have come down tremendously in price since I started out 3D printing.
But the thing is, they'll just normal stepper motors will still be cheaper in the end. So why not just put a bit bigger stepper motor on your 3D printer and then not worrying about feedback loops and everything, instead of having like a smaller machine with feedback, but that's just more expensive, but doesn't really give you that much benefits. Or what do you think?
Well, will the stepper motor actually be cheaper? Because the thing is, right now we're oversizing everything. We're oversizing the stepper motors. Most stepper motors that have like the standard 40 millimeter length, you don't actually need that long of a motor. A 25 millimeter or 20 millimeter unit even would provide you the same amount of torque and the same amount of reliability, and it's just a lot less material that you're using. You're using less copper, you're using less iron, and that naturally at scale is going to make the motor cheaper. And experience shows that electronics usually are one of the cheapest things in an assembly, and if you go to volumes, then something that is literally just dead weight is going to just pile up in cost and shipping. So I think I definitely see that possibility that we are going to see servo motors with a motor that is actually more closely matched to to what it's actually driving, and more it's using more of its capacity instead of a stepper motor that is just oversized to hell and just sits there for the one occasion where it might need its power because we're not optimizing right.
Well, we can already see that in professional machines. They usually have servo motors in there.
2D printers. Inkjets.
In 3D printers.
2D.
Okay. Yeah. Well, yeah. You have these in normal printers. You have these plastic discs with stripes on there for the decoder. Yeah, they're using that. You're right, and they're not expensive.
Well, how much of that is actually going into the machine cost, and how much are recuperating from ink cost? I mean, that's an entire different discussion. But
I don't want to start on that topic.
It's just a small DC motor and the encoder, and that makes it a servo, basically.
Yeah. But still, I think it just adds complexity, and for cheap printers, reducing complexity is something which is making the machine easier. And if it's working out, and especially for 3D printers, if you really know what loads you will have during your printing process, because the loads you have are just the acceleration loads of your print ahead and your print bed, plus a margin of safety, you can size them pretty well. But you have already been talking about the dynamic drivers, and they do something in between. They get kind of a feedback, or they are monitoring the stepper motor a bit, and that changes this system from an open loop control system to a kind of a closed loop control system. Not 100% a servo motor, but it's getting in that direction, and it's not adding complexity to the motor itself. And I think this is something pretty interesting. And we can already see the use of these features in like end-stop-less homing, in jam detection, and everything which is also connected to that.
Yeah. What the dynamic drivers can actually do, and that is actually very close to the method that servos use to kind of maintain their position, because the challenge in essence is, how do you keep track or keep the actual position exactly where your set position is? So if that drifts too much, if that the motor can't keep up and you get to that full step position, then your stepper motor is going to your stepper motor is going to skip, whereas the servo is going to pick it up and make up for that. Now, what a dynamic driver can do is, because it has that that sensing. I should just restart this podcast because I'm messing up so much this time. The dynamic drivers have that means of sensing what the motor is doing and how far offset it is from that set position. So if it gets further behind where it's supposed to be, it can do things like increase current. And that kind of scoots it back up to where it's supposed to be. So it does some sensing, and it also does the step loss detection. But the problem is, once the motor starts losing or it loses its first step, then it's really hard to really keep track of how many more steps it keeps losing, because the current's not going to be enough to keep it exactly where it's supposed to be. So it can't recover, but it can sense what's going on, and it can kind of prevent skipped steps from happening. Now, the reason why I put this topic in here is I've been toying with the idea of building just the mega printer. Building a printer that is so powerful in its linear motion and so rigid that it is not going to need things like acceleration. Because in essence, if you look at your print and you have, say, a Bowden system that is basically more of a pressure fit system, and you have low accelerations, you're always, well, even with high accelerations, you're always going to see that material over deposition on the ends where it slows down, but there's still pressure in your Bowden tube and in your hot end. And I mean, that's the reason why you get blobs at the at certain bits, and why you need retractions. If you had something that just keeps the tool head speed 100% constant all the time, possibly even at a relatively high speed, you're not going to have to worry about hot end lag or retractions or anything like that anymore, because it's just going to be a super smooth, consistent position of material, which is the fuse deposition modeling. But I don't know. It's definitely not going to happen with stepper motors. I see no way that those are going to be able to keep up with something like that. So maybe again, that idea, are we limiting ourselves by just using open loop steppers? I would say yes, we are.
Yeah. But again, to your point, then the mass of the print head and the rigidity of the machine, they also come into play again and might ruin some of the benefits of your fast printing. Maybe we are limiting ourselves a bit. But still, I think the printers are quite good. Quite well tuned at the moment. So the question is, how much do you well, how high is the effort to get to that position, and how much do you really gain from that?
That is true. That is true. And is it that point that, of course, a lot of people will disagree with? Is it like, hey, are we not already good enough? Is, even the cheapest printers, are the machines themselves now not the limit anymore? Are the users now the limit because they don't put the machines to good use? That is true. Of course, as an engineer, you kind of always look at, hey, how can we push this further? But yeah.
So with 3D printers, I haven't seen that much step losing. But with my CNC router, with my old one, and actually also with my new one, which even uses NEMA 23 stepper motors, I have the problem of losing steps quite often, and for CNC routing that can be quite fatal, because that leads to crashes of your tool into your metal part, and that does not only sound really bad, it also can hurt you and destroy the whole machine. So with like cheaper CNC routers, I would see it as a huge benefit of having this closed loop system, really servo motors in there, and avoiding losing steps, and therefore avoiding crashes and making your parts better in the end. And since they're still mostly more expensive than 3D printers, I would pay a little bit more to have servo motors in there, but it's not that common. Even on like medium expensive machines, they often just use really beefy stepper motors.
Yeah, I've actually looked into that in that entire research for what could be the ultimate machine. They actually make drop in NEMA 17 and NEMA 23 servos that basically just get a step in direction, and they have the same bolt pattern. You give them power, step in direction, and they're a bolt-in replacement for your NEMA 23 steppers. And the 23s are actually cheaper than the NEMA 17s. I guess it's just, again, volume.
Really?
I think that they're around $60-$70 per piece.
Okay.
Which isn't that bad.
No.
I think. Because a NEMA 23 stepper motor is already more expensive than a NEMA 17 by far.
Yeah. And just like ruining one of your like CNC jobs might even cost you more than the $70 there. If you have like a bent spindle, a ruined expensive carbide tool, and all of the things that are connected to that. Yeah. And for CNCing, it's always the thing you do not really know in the first place how high your forces will be that you get during the machine process. Yeah.
You could simulate it, but
it's not as simple as with 3D printers.
Right. And yeah, as you mentioned, the risk involved of a skipped step. If you lose a step in a 3D printer, like, okay, your print's going to be shifted. Whatever, you're going to reprint it. It's not going to permanently harm anything. It's just going to use up a bit of plastic, and that's it. With a CNC, at the very least, you're going to snap your bit.
Yeah. Which is not that bad if it's small, but the bigger ones, they are expensive, and they can bend.
Which, I mean, it's the reason why professional CNCs come in an enclosure with like 1/2-inch polycarbonate sheets on the ends, and sometimes on those machines you actually see small holes in them where it's like, oh, you can see that's actually a part that shot through and got caught in that polycarbonate sheet. And it becomes more of an issue if you have like larger tools and more powerful spindles that can actually shoot a part out of the vise and into the side of the machine. It's not uncommon. That's why you have enclosures. On the smaller machines, it's still risky. It's still like using a laser cutter without an enclosure, right? It's still not perfectly safe.
It's not perfectly safe, but it's always a nice feeling having like your own CNC part in the end, or just like watching your CNC router make chips and not sounding horrible. I enjoy it, and I was really missing that.
Yeah, and for me, I mean, the MP CNC is still waiting to be built. I'm just trying to find the right time for that. Now the taxes are done. Yes!
I also just got my tax report today.
Yay! Yeah, now it's time for me to start in 2018. Well... But
Yeah.
that's probably one of the most boring topics to talk about. So let's move on.
Yeah.
Yeah, MPC and C, all the parts are here. Everything's printed, just waiting to be built.
Cool. Just one small question regarding that. Will you be using Gerbil or will you be using Linux CNC?
I'll be using the Do It 3D.
Ah, yes. Yeah, you told me that. So,
yeah. Trinamic drivers, NEMA 23 capable. I'll be using NEMA 17s, but yeah, Do It board. I don't know if it's a waste to put that into a CNC, but why not use it? It's got the most powerful drivers I have on any board, so it can't hurt on a CNC.
Yeah, no, definitely not. Better overpower your stepper motors. Yeah. All right. Yeah. So, topic of the week. You just said that you had been outside with a dog and thought about the world and everything. And you thought about if 3D printing made the world a better place. Can you just talk about that for a couple of seconds that we can get into that conversation?
Cool. So basically, the argument that you're going to hear from a lot of people that see 3D printing from the outside and also from the inside where people, print stuff and, actually look back at what they've printed is like 3D printing is fantastic. Yeah. But is it really something that is moving mankind forward? Humankind? People kind? Or is it just another thing that people can waste their money on and create more trash that they're going to throw away with import printers that who knows are going to be built under what conditions, that use metal and plastic and electronics and use up resources, and then they use the plastic and use up valuable oil-based products basically, and create more plastic waste. And yeah, the question is overall, I mean, I'm sure there are way more people that are just buying a 3D printer and printing like little gadgets and trinkets off of Thingiverse than there are people actually getting a 3D printer and putting it to good use. So overall, do the pros outweigh the cons? Are we part of something good here?
Yeah, so trash is always a thing, but there are great applications for 3D printing, and fidget spinners aren't one of these great applications.
Absolutely.
But even though many of these things, or many people just buy a 3D printer, download things on Thingiverse and print them out, it has opened the possibility for engineers to get their ideas much faster into a product. And if you're taking a look at prosthetics, for example, these things were horribly expensive in the past, and 3D printing might be a possibility to make these things cheaper and more accessible, especially if you're not taking a look at like Europe or the USA. Because if you have the print files available, you can print them anywhere for like no money at all in the end, and give capability back to people that, well, they didn't have before.
Yeah, but it's not just about the ability to now make things more freely and not have to pay for a company's patents and stuff and pay that ridiculous markup that many medical products have. 3D printing, I think, is great where it's one-off parts, because if it would just be let's say a standard arm prosthetic part. Somebody loses their hand from the hand joint. If that was just the wrist, that's the word I'm looking for. Somebody lost their hand from the wrist. If that was like a standard application, you could injection mold every single part, right? You could just make a mass manufactured thing. But then again, not every person is the same. And 3D printing is great for that because it allows you to customize every single part you make, which is again something that injection molding doesn't do unless you're also starting machining on the end product then. But yeah, that capability of making things that are specifically catered towards what you need. And we've touched on that before, like Did we talk about that on the podcast? No, we talked about that before, right? Where it's what are people actually using these machines for, and how many are putting them to use?
Yeah, but this is one thing: customizability of parts, making parts really in the way they are needed, in the color they are needed, and well, accessible all over the world. And this is something really great. But also, it's well, you see that on television at the moment. 3D printing is not only like printing plastics. Maybe we start 3D printing houses later. If you take a look at,
I'm still not convinced about that.
If you're
for
taking a
various
look
reasons.
at about mooning or Mars projects, thinking about like 3D printing or building shelters from the materials that are available there, and maybe this is also something a thing that might be feasible for the future and make things more affordable or even possible. I don't know.
Yeah. Okay. So first of all, the 3D printing houses thing. That is a very well marketed story and narrative, because what people are being told is like, hey, you can 3D print this thing for what, 4.5K, and then you've got this house. But basically that is just a concrete shell that you're getting. You could cast that thing for way less and have the same result. It's not got any insulation, it's not got any electrical, plumbing, it doesn't even have floors in it. It doesn't have any furniture finishing, nothing. It is literally just the concrete slab that costs that much, or the concrete
great
cube
industrial
or whatever.
look.
Say again?
Great industrial look.
Yeah, well, if you want to live in a box with nothing in it, then I mean, I'm sure there are better options to achieve that.
Yeah.
So the 3D printing houses thing,
Yeah, sorry.
I feel like there are better ways to achieve that with like prefab and all that. That's coming along.
But also, well, speaking about wasting resources, 3D printing can also be used to save resources because, for example, I am a mechanical engineer working in a machining shop. If we like machine a part out of metal, we usually take away like 70, 80, 90% of the material that was the rough part before. Even though 3D printing also does not create the final part in the end, but kind of the only thing you need to do is creating the rough external part, like taking 10% of the material away, and then you have your finished part. And you can reuse all the powder that was still in the machine and create a new part out of that.
Yeah,
metals are
right?
recycled. Metals are recycled, but still, you don't need to use as much material in the first place compared to conventional methods. And this is also not like 100% true, because also like making powder for metal machines wastes or takes a lot of energy. You have different steps you did not need with conventional parts before. But I guess it's getting into the right direction. And also, it's not printing houses, but printing food. Guys who might be doing space travel later, they don't want to eat and drink just juices and pastes in the end. So you can have like some raw parts and create like chewable, recognizable things out of these generic parts. This is also 3D printing might make them more happy in the end. Also an application. I don't know. I'm getting a little bit off here.
Yeah, well, I mean, there's so much that is hype and marketing and kind of overhype, basically.
Yeah.
Again, 3D printing food. As with any 3D printing process, the materials that you get out of the process are the same ones you put in. It's just in a different shape. So if you have, if you want to print a burger, you're going to have the same ingredients as with a normal burger somewhere. It's just the machine is just assembling it. That's the core idea of a 3D print. And everyone who's used the filament printer is going to know that if you put ABS filament in it, you're going to get an ABS part out of it. But yeah, there are good applications. And the question is, how can we encourage those applications? How can we keep people from just downloading Thingiverse trinkets? Not that Thingiverse is a bad site on the internet. It's actually fantastic. But and I think that part of 3D printing, where it's just the exploration and the toying around with it, is also very important, because it engages people and kind of gets them hooked in the first place. But
yeah, this is one of the things we both are doing. We are showing what else can be done with 3D printing besides printing fidget spinners or things like that.
Yeah, fidget spinners aren't even cool anymore.
Yeah, sorry. I'm so like 2017 or I don't know.
Yeah.
It's a great tool. It's not only a great tool for engineers, because I would have loved to have such a tool like 10 years ago when I was doing my bachelor's. Designing something, like pushing a button in the end and get a final part out of that. That's great. And this is something where 3D printing is so beneficial and is making me happier, or enabling me to create parts, iterate on my ideas. And this is something cool. But also take a look at designers. There are lots of 3D designers out there who are doing their designs in on the PC in 3D modeling software and things like these. It enables them to make physical objects out of their ideas which they had before, and this is also something great. And they can share it with the world.
Yeah, it's that. I guess it's a common theme here, is wherever people have the ability to design and create those one-off parts and one-off designs, that's where it really clicks, where it really makes sense. So whether it's CAD, whether that's sculpting on the PC, whether it's making artistic things, I mean, even prop making. 3D printing has quite the stigma in the prop making community, because it's like, oh, you're not put any work into that, you just print. But it's still super powerful, and I mean, that's the point, right? You just hit print. Yeah, you put the work in before on the computer, but the process itself has become so much simpler versus manually. I don't know how like sculpts or props are made. I don't know, cutting out cardboard shapes and then sculpting it over with clay, or I don't know. It takes out that manual, labor-intensive work. Are we killing jobs? Hold on.
No, we're not.
No, okay.
No, we're not. We're just shifting jobs.
Right.
But maybe also one thing which is really interesting to talk about is spare parts. One of my most viewed videos is where I designed a replacement gear for a salad dryer, which was broken. Took it apart, measured the gear in there, printed a new one in PLA, and it's working great ever since. Otherwise, I would have thrown away the salad spinner. Replacement parts are not readily available today for your household items, but this could be something in the future where we could avoid making more waste, giving us the possibility to just print replacement parts, not having to throw away the whole machine. I don't know. I think this will also be something really great.
Yeah. There's this one story that I've picked up once where it's a guy had to justify buying a 3D printer to his wife, and as it goes, he's looking for applications, and one day his hat rack, one of those extendable hat racks that you have in what are they called? Station wagons. US doesn't know them. They only drive the limousine style. But the hat racks, the extendable ones that you clip in on either side, right? And one of the clips broke on one side, and it wouldn't clip in properly anymore. They went to the dealer. They were like, hey, can I get just this one end cap? And they were like, no, you have to buy the entire thing. And it was like 1,200 euros. So yeah, calipers, drew up the thing, printed it, glued it on, perfect, works. Saved 1,200 bucks, paid for the printer, basically justified it to his wife, and saved on having to buy an entirely new unit just because a little plastic tab broke out. So those sort of applications, again, they require CAD knowledge. They require being able to customize your own parts. I don't know if it's going to be possible to create like a library of replacement parts. Unless there's manufacturers actually playing along where it's, appliance manufacturers that publish a library of, hey, we've got this one pulley for this washer that you could reprint if it breaks, or we've got this bottom casing for whatever that you can print at home, or at least can have printed out in a Home Depot or home improvement store, where they have a machine that is set up with that set of parts that you can go in, hit print, and you stroll through the store. 45 minutes later, it comes out, and it's a perfect drop-in replacement.
There isn't something dedicated for that, but to be honest, if you have a problem with one of your, for example, IKEA furniture parts, there is like 99% somebody else who already broke it, redesigned it, and put it on Thingiverse. So
most likely, yeah.
Yeah, most likely. And also for plenty of other things. I'm sometimes really stoked to see how many replacement parts are in there for appliances. I wouldn't have even known that there are many people on the planet who own the same thing. So yeah, there's nothing dedicated for that yet. Business idea.
Yeah, but it's been thought about and I think even tried before. But the problem is always, hey, are we just gonna get copies somewhere? Is somebody just gonna grab our designs, put them together, maybe fill in the gaps, and then there you go. There's an exact clone of this product that we spent months or years designing.
Yeah. Well, it's kind of bad for appliance manufacturers because they kind of want you to buy, new stuff. So if you're printing out replacement parts for the machines, yeah.
It's not just appliance manufacturers. It's that entire idea of planned obsolescence, right?
Yeah.
Here we go. Down the rabbit hole we go. Ooh. 3D printers are horrible for that, because if you suddenly give everyone the ability to fix things instead of buying new ones, then what's going to happen to our economy? One of our German ministers actually recently commented on the discussion about, hey, should we be reusing more of our plastics? Should we introduce the entire reusable plastic bags or cloth bags, shopping bags? And well, no, I think it was deeper than that. I think it was even laptops right to repair, something like that. And the comment was, no, because economy, and I'd rather have the Kreislaufwirtschaft, so like the circular recycling economy. And that might be a structural issue that he can't really fight against with giving people the ability to repair.
Yeah.
Then manufacturers aren't dumb either. They're going to find new ways to keep you from using the same thing for longer.
Yeah. And to be honest, 3D printers and also the materials we are currently using are not always suitable for the applications and the loads that you also have in your appliances. Yes, they are strong, but often they are not as strong as injection molded parts if you don't have a lot of knowledge. But you were talking about like hardware stores. You could have dedicated stores with proper machines and proper people who have knowledge about using these machines to create these replacement parts for you, that they function the same way as the old part, or even better, because usually the parts that break, they have kind of a design flaw.
Yeah, they break for a reason, right? If it's not your kid knocking something down, usually it's because well, either they've been intentionally designed with a weak spot, or just was an oversight in design.
Yeah.
One thing we've touched on like making one-off custom parts, but just the entire idea of like making things pretty and making things look the way you want. I think that is incredibly powerful as well, for acceptance of various things, like prosthetics. But also people have been using it for light switch plates, printing custom parts. That is, it might not be, from an engineering standpoint, it might not be something that is really pushing society forward and enabling new things, but it still makes people happy, right? And isn't that worth something as well?
Yeah, definitely. Yeah, so we have already been touching a little bit that if you have a 3D printer, it's good if you know CAD. 3D printing, even though it's really accessible at the moment, is something that, even though it's accessible at the moment, is still something you need kind of a knowledge. And that is kind of gets me into our question section, where Totally Glicht for asked about research groups and education programs about additive manufacturing. And I just wanted to talk briefly about that, since I kind of do lots of research projects with other German institutes and universities. And for the last 10 years, there have been many programs been set up at university and institutes that really go into details about additive manufacturing. And if you are a student at the moment doing your bachelor's, or if you're still a student in school, there are many programs around where you can get really deep knowledge in additive manufacturing. So I can only talk about Germany right here. In Munich, there's something. The University of Paderborn is doing lots of things. The University in Hamburg, together with the Fraunhofer IAPT Aachen, they are doing lots of photonic research, laser research, additive manufacturing. So there are many programs at the moment around where you can get deep knowledge in 3D printing and helping in the development of 3D printing for the future. So yeah, if you are interested in that, just research a little bit. There are lots of programs available here in Germany, and I'm quite sure also anywhere else on the world at the moment.
Yeah. Do you know how they tie into like a regular degree? Is it like an extra thing you take on, or does it give you ECTS points, or how integrated is that?
Yeah, many of the guys I'm working with, they are PhD students, so they are doing their PhD in this direction.
Right.
Many have been studying mechanical engineering before. There are master degrees which are going in that direction. There are also master degrees in polymer techniques who go more into the direction of additive manufacturing. Yeah, so there are separate programs where you can also earn ECT points for masters here in Germany. But also, if you want to do your PhD after that, there are lots of institutes where you can take a look at these things. And if you're interested in that, one venue which is always interesting to take a look at is the Formnext in Frankfurt every year, because lots of these universities and institutes have booths there and talk about the things they do there. And the Fraunhofer Institute is one of the, it's probably the biggest research booth there, and they do everything. It's great.
Yeah, Fraunhofer does everything. I mean, just in general.
Yeah. So
very nice.
Next question. Shane Duggar wouldn't ABS, so we have been talking about ABS versus PETG in the last podcast, and he was asking, wouldn't ABS be considered the best filament for auto parts where high heats is... Oh, damn it. I should have enlarged my window before. So he's asking, wouldn't ABS be considered the best filament for auto parts where high heats is an environmental factor?
Yes. Very simple answer. Yes. Out of those two, out of PTG and ABS.
Yeah.
ABS is definitely the better option.
Yeah. ABS is usually usable up to 100 degrees. It's getting really soft at 105, 110 degrees. So that's a good choice. If it is an external part in your car, use ASA because it's more UV resistant.
Or polycarbonates, those sort of materials.
Yeah. Totally usable there and already applied today in car manufacturing.
Yeah. ABS still one of the most common parts, whether that's straight ABS, ABS PC or PC ABS, ABS plus fibers, that entire group. And I guess the good thing about ABS is it doesn't change when exposed to heat. It doesn't crystallize. It doesn't do any of those things. It just stays the same. So it gets exposed to that heat, it cools back down, and it's the exact same plastic as before.
It's just getting a little bit soft and deformed.
Well, if there are no major loads applied to it, then yeah. But also, what are bumpers made out of? Are they ABS or are they some other P something?
I don't know if polypropylene is maybe also used in some applications because it's more deformable, is a little bit softer. There aren't many cars around today anymore where you really have these black bumpers.
Well, they're still all plastic, right?
They're still all plastic.
Painted.
Yeah. I gotta check that. Would be interesting to know.
Yeah, PP apparently, according to thebumperguys.biz, PP is being used. PUR, so polyurethane, is also used. PVC, ABS, poly. Well, why are they listing? They're just listing.
Everything.
Okay, whatever. They're listing every single polymer. Okay, worthless. But yeah, to conclude that question, yes, ABS is an excellent material for auto parts, definitely. And last question for today, why don't you guys use DaVinci Resolve for video editing? It's great. We got suckered into Adobe.
Yeah, I have been using Adobe Premiere for the last 15 or even 20 years.
Oh, that's okay.
Yeah, I did.
My experience doesn't go quite as far back.
No, I did my first like editing things back when I was 13, 14. Also,
I was using Windows Movie Maker back then, which is, by the way, great software. Just doesn't do a lot
for simple things. Yes. Yeah. So I have been using it for ages, and this was the reason why I also bought myself Adobe Premiere or the whole Creative Cloud when I was starting YouTube. It's yeah. If you're changing your tool chain, it's always such an effort. But to be honest, I only use like 10% of the features, or even less, that Premiere is offering. So a more simple tool might be a thing.
Yeah, but then again, DaVinci Resolve isn't a simpler tool. It does most of the things that Premiere does, actually. So if you look at color, especially, DaVinci Resolve usually or originally was a color tool. So just all the stuff that's coming into Premiere now, where you can do hue over hue curves or hue versus saturation, those sort of things. That's always been in Premiere, in DaVinci Resolve. It's been great for that. So right now, Premiere is playing catch up with Resolve and not the other way around. And I've actually been thinking about switching to Resolve, just because, I mean, the $60 a month isn't horrible, but it does add up, and I'm not always totally happy with Premiere either. But like you said, switching over is hard. I've got all my plugins for Premiere. I'd have to rebuy all of those. I know my workflows. I know how to export to Audition, which I also use for every single video. I do audio processing in addition, and it would be extra steps out of Resolve to get a WAV file out and then use. I mean, if I need Audition, I'm still gonna have to pay for the Creative Cloud, so I'd have to use.
Well, you can use Audacity.
Audacity, but then again, Audacity doesn't do. Well, I guess it does most of the things. Noise removal, I guess.
But you're also probably using a Photoshop and I don't know, Lightroom maybe.
True.
It's just
true.
a nice set of tools. It's expensive, but
yeah, I do use Photoshop, but I don't need Photoshop. I could use GIMP just as well. GIMP does everything I need out of Photoshop.
I always use it from time. Well, we have it at work because it's free. But I just don't really get along with it.
It's a different. It requires a bit of a different mindset. But I started out using mostly GIMP in my. How old was it? Oh crap! That was 10 years ago. Huh! First business with a buddy. We were building PCs, and all the graphics I made for that were done in GIMP, and I got along with it just fine.
Yeah.
So
whatever you used to.
Absolutely, but if you're looking for video editing software that you want to start out with, don't start out with Premiere. Start out with DaVinci because it's free, and if you need the more capable version, it's just like a $220 upgrade to a 8K workflow and whatnot. Yeah, use it. It's great. It does so many things that Premiere maybe doesn't even do. So yeah. If I were to start again, I would definitely be using Resolve.
All right, and I think that concludes it for today.
Yeah.
Thanks, Tom, for your time.
We've done it. We've done it again.
Yeah, and we are just at the hour mark, or are we above the hour mark?
Oh, did you hit record too late? I'm at 1 hour and 9 minutes.
Yeah.
Podcast's probably not going to be quite as long, but yes, thanks everyone for stopping by again. Thank you for watching, listening. Stefan, are we already on Spotify?
No, we still need to exchange the jingle in the WAV files. Podcast files.
Yeah, because that's Epidemic Sound and the licensing. But they said it was okay.
Yeah,
Epidemics. I've got written confirmation from Epidemic Sound, so should just reapply.
Maybe
to
it's
that.
the easier thing to just add the new jingle and then we're fine.
Re-render.
And I've just noticed that I have a new app on my phone which is called Google Podcast, Play Podcast. Is there? I don't know if I just didn't notice it before.
Is it part of Google Play Music? Maybe
could be the case since I have the premium subscription. Well, anyways, not on Spotify yet.
Are we on Google?
Didn't check that. Somebody was complaining that it didn't properly load in some Google player. I'll check that out later.
Yeah, definitely let us know if you're still missing from various places. But the goal is to be just on every single platform out there. Maximum availability. All right. See you again in 2 weeks. And goodbye.
Goodbye.